Welcome back to G Fun Facts Online, where we dive deep into the science that shapes our world. Today, we're on a quest for white gold lithium. It's the powerhouse behind our green revolution, fueling everything from electric cars to smartphones. But the journey to understand where this lithium comes from has led scientists into a surprisingly alien chemical world, a realm previously unknown, and now, it's rewriting the textbooks. For a long time, we thought we had a pretty good handle on the chemistry of salty waters, like our oceans. The main idea was that carbonate minerals were the big bosses, controlling pH and alkalinity. That's water's ability to neutralize acids. This seemed to be a universal rule. But then, scientists started looking closely at the massive salt flats, the salars, in South America's Lithium Triangle and the Tibetan Plateau. These are the places where about 40% of the world's lithium is extracted from brines deep beneath the surface. And what they found turned the old rules upside down. The star of this new chemical show, boron. Yes, boron, an element we're familiar with, but playing a role no one expected. Professor Avner Vengosh from Duke University, who led much of this groundbreaking research, put it perfectly. We discovered that the pH of brines in these regions is almost entirely driven by boron, unlike seawater and other common saline waters. This is a totally different geochemical landscape, like studying an extraterrestrial planet. This alien chemistry is all thanks to incredibly high concentrations of boron found right alongside the lithium. So how does boron pull this off? In these lithium-rich brines, boron isn't just one thing. It exists as boric acid and various borate compounds. The balance between these forms dictates the brine's pH. Now, think about how lithium is usually extracted. The brine is pumped into huge, shallow evaporation ponds. Under the intense sun of these arid, high-altitude regions, the water evaporates, and the lithium and boron get more and more concentrated. Researchers noticed something fascinating. While the natural brines from the salars are usually around a neutral pH, the brines in these evaporation ponds become increasingly acidic, and boron is the culprit. As evaporation concentrates the boron, it causes boric acid to break down. This breakdown releases hydrogen ions, and boom, the pH drops, making the brine more acidic. Gordon Williams, a lead author on a key study, explained that through a chain of geochemical reactions, the usual carbonate alkalinity gets pushed aside, and boron alkalinity becomes predominant. In fact, this boron-driven system can account for a whopping 98% of the alkalinity in these brines. This wasn't just a one-off finding. Scientists compiled a geochemical database with over 300 lithium brine analyses from all over the world: Chile, Argentina, Bolivia, the Tibetan Plateau. And the models consistently showed the same thing. Boron was the main influencer of alkalinity and pH in most of these brines. This new understanding of boron's power is a game changer for lithium mining and how we manage its environmental impact. First, optimizing extraction. If we know boron controls the chemistry, we might be able to tweak the pH changes to recover more lithium, making the process more efficient. Second, wastewater management. Those evaporated brines become acidic because of boron. Knowing this is crucial for safely managing wastewater and spent brines, helping to prevent environmental problems like acidification. And it's not just boron. Other elements like arsenic can also get super concentrated. Third, boron co-extraction. Boron itself is valuable. It's used in ceramics, glass, and agriculture. So, with such high concentrations, there's potential to extract it as a byproduct, though its presence can also make purifying lithium a bit trickier. And fourth, predictive modeling. This research helps us better predict how brines will change during evaporation. This is super useful for designing and running those solar evaporation ponds more effectively, as even the precipitation of borate minerals can change the whole chemical pathway. So why are lithium and boron found together in such high concentrations in these places? It's a story written by geology and climate over vast timescales. The primary source is the leaching of lithium and boron from volcanic rocks in the surrounding Andes and Tibetan Plateau. Geothermal activity deep underground can also help mobilize these elements. Then there's the climate. These regions are hyper-arid, and the salt flats are often enclosed basins. This means water flows in, but the only way out is through evaporation. Over millions of years, this extreme evaporation concentrates solutes like lithium and boron. And finally, water-rock interaction. As water journeys through the landscape, it picks up these elements from rocks and sediments. The type of interaction, whether it's gentle weathering at the surface or deep, hot geothermal circulation, shapes the initial chemistry of the brines. Of course, with new discoveries come new challenges. Boron, for all its influence, can be a bit of a troublemaker when it comes to getting pure lithium carbonate, which is what many batteries need. So, research is ongoing to find smart ways to remove boron impurities or manage its effects during processing. For instance, scientists are looking into using certain types of alcohols to help reduce how much boron gets trapped in the lithium carbonate crystals. This alien chemistry, where boron calls the shots in lithium-rich brines, really highlights the diverse and sometimes mind-boggling geochemical systems our planet has cooked up. As our world races towards decarbonization, the demand for lithium is only going up. Understanding the fundamental science behind its deposits, like this surprising role of boron, is more critical than ever. This knowledge doesn't just promise to make lithium extraction more efficient and sustainable, it also deepens our appreciation for the complex chemical dances happening in Earth's most extreme environments. The exploration of these boron-lithium systems is far from over, and it's sure to bring even more valuable insights for how we use our planet's resources and understand its fundamental workings. And that's our deep dive for today on Fun Facts Online. Fascinating stuff, isn't it? Join us next time for more surprising science. Don't forget to like, subscribe, and hit that notification bell so you don't miss out. Until then, stay curious.